Today we're doing the 10.6 extension, generating multiple samples. So for the first type of problem, they're going to ask you to make a box and whisker plot of data. And usually we're going to use this where we're looking at more than one set of data. But right now I just want to go through the steps for box and whisker in case you didn't do this last year in 6th grade. So the first step on a box and whisker is to order our numbers least to greatest. So that's what I'm going to go ahead and do here. So I'm looking at my numbers 65. I'm going to go ahead and just cross them out as I write them, and that way I know I'm not missing anything. 76, 77. Looks like 80 is, oops, I missed 73. I'm going to squeeze it in here. 65, 73. All right. Okay, 80. I've got 83. I have two 84s. 84, 84. Okay, looks like next comes 94. And I have a 96. And then I have two 98s. It's always a good idea to count up your numbers. Make sure you have all of the numbers there. So this table had 12 numbers, and if I count my list of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I did get all 12 written down. Okay, so the next step is to find the median. So the median is the one in the middle. Some people like to cross out or check mark, so like 65 and then 98 and then 73. I'm not actually writing on my numbers because I'm going to need them in a minute. But you can keep going back and forth that way until you find whatever is in the middle. Now, I have two numbers in the middle, 83 and 84. That's because I had an even number of numbers. So when I have two numbers that are in the middle, I have to find what's halfway in between them. So that's going to be 83 and a half. If you're ever not sure what's halfway in between, then you can average them. You can add 83 plus 84 and divide by 2, and that'll give you whatever is in the middle. So that's our median. Now I have to find the median of the bottom half and the top half. So I'm going to look at the bottom half. I do not include my median in there, but since 83 wasn't really my median, I am including that number. Now I can continue to go back and forth, or I can count and say I have 6 numbers. So my median for this half is going to be in between 76 and 77. That's going to be 76 and a half. That number is called our first quartile or our lower quartile. That just means median of the bottom half. Okay, now I'm going to do the same thing on the top half. So I need to find the median of my top half of my numbers. So I have 6 numbers on this side. My median is in between numbers 3 and 4. Halfway in between 94 and 96 is 95. That number is called my third quartile or my upper quartile. So median is like really the second quartile, and then my third is my 95. When we make our box and whisker, we need 2 other numbers, and that's the greatest number. On this one, it's 98, and the least number, which is 65. Those 5 numbers are called the 5-number summary. It gives us a little bit of data about the numbers and how far apart they're spread without actually having to look at the whole list. If we were going to share this information with someone else, that's where it's kind of useful. Instead of having to sort through the whole list and figure it out from a table, the box and whisker plot, once you make it, allows someone else to look at the data and understand it quickly. You do not have to make your number lines going up by 1s. I'm going to make mine going up by 5s. But you do need to make sure you pick a consistent interval. And you do need to make sure that you have enough numbers for all the numbers that are on your 5-number summary. When you have a story problem situation, you do need a label at the bottom. This one looks like scores on a science test. So I'm going to go ahead and write that same information underneath it. Often you see the title for a box and whisker underneath it, but sometimes you see it above. You could do it either way. Okay, so now I'm going to do the box and the whisker. The box is made up of the first quartile, the median, and the third quartile. They form a box. So I put a point for each one. 76 and a half, you just have to kind of estimate where that is. 76 and a half. 83 and a half, again, you kind of have to estimate where that is. And then the third quartile, 95, I do have 95. So now I'm going to draw a line, vertical line through each one. Don't go all the way down to the number line. And then I'm going to connect them to form a box. So now I need to make my whisker out to the lower quartile and the upper quartile. So for my lower one, my least value was 65. This is the whisker part. And then my upper one was 98. Okay, so that's my box and whisker plot. I put my 5 numbers that I circled onto the graph. That box shows me the middle half of where the data is. Okay, so for our next problem, and I have the work on here just to save time because it would be a long time for me to go through all of this myself. It says you want to know the mean number of hours of students with part-time jobs work each week. You go to 8 different schools. At each school, you randomly survey 10 students with part-time jobs. Your results are shown. So remember for the mean is when we add up all our numbers and divide by the number of numbers. Divide by number of numbers. Okay. So that's what I did here. So for example, number 1, I added 6 plus 8 plus 6 plus 6 plus 7 plus 4 plus 10 plus 8 plus 7 plus 8. I added them all up. I got 70. I divided by 10 because there were 10 numbers, and then I got 7. I did the same process for all the other rows. I didn't write down all the work, but that's what I did. And then I wrote down my answers for what I got for the mean for each one. Then I need to do my box and whisker plot. So I'm going to order them least to greatest, which I did up here. So I had my numbers, my 5, 5, 7. Here they are, 5, 5, 7, 7.3, 7.7, 8, 11, and 12. And then I did my 5 number summary. So I crossed off side to side. I found 75. That's my median. I looked at my bottom half, which was this part. Found the median for that. It was halfway in between 5 and 7. That was 6. That's my first quartile. Then I did the same thing on the top half. I looked exactly in the middle. I found what my third quartile was, and then I circled my least and my greatest. I made my 5 points for my least, my first quartile, my median, my third quartile, and my greatest. Those numbers I circled. I put the points above the number line, and then because it's a story problem situation, I wrote hours worked as my label on the bottom. Okay, so let's take a look at this one. It says another way to generate multiple samples of data is to use a simulation. We looked at simulations in the 10.5 extension. So it says, suppose 70% of all the 7th graders watch reality shows on television. So step 1, design a simulation involving 10 color chips by making a bag where 70% of the chips are the same color. So in order to do that, I would say, okay, we have those bags of red and black chips that we use in class. So I'm going to say 7 were red, and I'm going to say 3 are black out of my 10 chips. That gives me 70% that are the same color. So 70% are red. And then it says simulate choosing a sample of 20 students by choosing a chip from the bag and replacing the chip each time and record the results. So I'm going to go ahead and do that. And once I did that sample, I had 20 times I chose my chips. And out of those 20, I got 15 reds. So those were my results. Okay. And then it says you will compare your results. How much variation do you expect? And explain. So, oops, I don't know. Okay, so are you going to get some variation? Of course, not everybody's going to get the same amount, but we could use that to help us make an inference about how many times we think the amount of 7th graders watch television, reality television shows. So that's very similar to what we did in 10.5 extension.